Hi there! Good day, Olivarians. I am Mr. Jason Lumagas. You can call me Sir Jason. I am from the Dr. Pablo R. Olivares Senior High School Department at Olivares College, Parañaque. Welcome to our NS001 virtual class. Earth Science for STEM students, Earth and Life Science for non-STEM students. I am your instructor for the first part of Module 1. Are you excited to know more about the natural world? Join me now as we explore the fascinating, incredible, and exciting planet Earth. So let's get started. Our first topic is about the origin of the universe and the solar system. In this topic, we'll basically talk about the beginning of the universe, the beginning of everything. How the universe, the solar system, and other celestial bodies were formed. In addition, we will also talk about the different characteristics of Earth that are very essential to support life. After finishing this module, you should be able to first, describe the historical development of theories that explain the origin of the universe. Second, you should be able to compare the different hypotheses explaining the origin of the solar system. And lastly, you should also be able to discuss the different characteristics of Earth that are necessary to support life. Before we begin the discussion, I would like to ask you some questions. What is your idea on how the formation of the universe began? How the planets and other celestial bodies such as the sun, moon, and stars were formed? How did it all come into existence? Think about how. The formation or the beginning of the universe is just one of the many things in science that cannot be easily explained. Several cultures believe in universal creation, as observed in their own unique stories, lore, and creation myths. There are also scientific theories explaining the earliest beginnings of the present world. Let's now first describe what a universe is. What do you mean by the word universe? Other term for universe is cosmos. The universe, as we currently know, it comprises all space and time and all matter and energy in it, which include the solar system, all stars and galaxies, and the contents of intergalactic space regarded as a whole. In short, when we say universe, it consists of everything that exists anywhere in space and time. Let's know first the composition of the universe. The universe as a whole is primarily made of 71.4% dark energy, 24% dark matter, and about 4.6 baryonic matter. What are these compositions? How do they differ from each other? First, when we say dark energy, it is a source of anti-gravity, which is an imaginary force that counteracts gravity and causes the universe to expand. Dark matter, on the other hand, is a kind of matter that has gravity, but does not emit or produce light. It also holds the galaxies together. This kind of matter cannot be seen with telescopes, and it is believed to account for most of the matter present in the universe. And lastly, baryonic matter refers to all objects made of ordinary matter, which include protons and neutrons, that comprises atoms, planets, stars, galaxies, nebulae, and other bodies. With regards to the age of the universe, based on the recent data, the universe is about 13.8 billion years old. There are two ways by which astronomers estimate the age of the universe. First is through estimating the age of the looking oldest stars. Secondly is through by measuring the rate of the expansion of the universe and estimating back to the Big Bang. Let's now talk about the different theories on the origin or the beginning of the universe. First, we have the divine creation theory, which is about God. Next, we have the different creation myths, which are non-scientific thoughts about the universe. And lastly, we will talk about the different scientific theories, which are all based on science. Let's begin with the divine creation theory. This theory is also known as creationism. What is this theory all about? Creationism is the belief that the universe and the various forms of life were created by God out of nothing, or in Latin words, ex nihilo. This belief is simply based on the Bible. According to the book of Genesis, there was a supernatural being, which is God, who made the entire cosmos or universe that took place in 6 days. On the first day, God created light, where He divided light from darkness. On the second day, God created the atmosphere. Dry ground and plants appeared on the third day. The sun, moon, and stars were made on the fourth day. Living creatures such as birds and sea animals were first seen on the fifth day. On the sixth day, God created the land animals and humans. And on the seventh day, it served as a Sabbath day. So that's all about the divine creation theory. Next, we have the creation myths. Creation myths are non-scientific thoughts about the creation of the universe. These are symbolic narratives of the beginning of the world as understood by a culture, which are handed down from generation to generation through oral traditions such as stories, poems, songs, and works of arts. Do you know, students, any creation myths pertaining to the beginning of the universe? Some Asian cultures believe and attributed the origin of the world in so many gods. They believe that these gods cried and their teardrops became the oceans. In Egypt, they also believe in many gods and myths. They believe that the world arose from the infinite sea at the first rising of the sun. In Central Africa, they tell the story of a creator who felt an intense stomach pain and then vomited the stars, sun, and moon. While in India, there is a narrative that gods sacrifice Purusha, the primal man whose head, feet, eyes, and mind became the sky, earth, sun, and moon respectively. Those are examples of creation myths. Let's now see how science explained the beginning of the universe. We have 4 main scientific theories. First, we have the Big Bang theory. This theory is the leading explanation about the beginning of everything. While the majority of the astronomical community accepts the theory, there are some theories who have alternative explanations aside from the Big Bang, such as cosmic inflation theory. We also have steady state theory, and lastly, the oscillating theory. Let's begin with the Big Bang theory, discovered by Alexander Friedman and George Lemaitre in the 1920s. According to the Big Bang theory, the universe began with a massive and rapid expansion around 13.8 billion years ago. We can see in the photo that the universe began with a very tiny, extremely hot and dense energy compacted in a single point called singularity to its present size and much cooler state. It caused space, time, and energy, including light, to exist in all directions. This expansion also resulted into several events that led to the creation of different forces and celestial bodies known today. But where did this singularity come from? We do not know. Why did it happen? we do not also know. What we only know are the events that happen during and after the Big Bang. Let's now talk about the evolution of the universe according to the Big Bang Theory. We can see here the timeline of the Big Bang Theory with description of each event. We can see here what really happened during the first few seconds up to the present time. It started from the inflation epoch, where all matter and energy in the universe existed as a hot, dense, tiny state. It then underwent extremely rapid exponential inflation until conditions allowed the existence of fundamental particles and forces, which eventually followed by the formation of basic elements and energy in the form of radiation, which is called cosmic microwave background. As the universe continued to cool down, matter such as in the form of stars and galaxies and other celestial bodies were formed. During the Big Bang, there were four basic fundamental forces that were formed, which include strong nuclear force that binds protons and neutrons together in the nucleus, electromagnetic force that binds atoms into molecules, weak nuclear force which breaks down an atom's nucleus and produces radioactive decay, and the gravitational force which binds the solar system. These four basic fundamental forces are needed in the formation of different matter in the universe. Let's now discuss the three main evidences supporting the Big Bang Theory. One is the discovery of the redshift, or also known as the Hubble's law, which led to the theory of the expanding universe, which was discovered by Edwin Hubble in 1929. Hubble found out that the stars are not uniformly distributed in space. Instead, they gather together forming clusters called galaxies. Astronomers used the term redshift before when describing how far away a distant object is. Redshift refers to a shift in the frequency of a photon toward lower energy or frequency with longer wavelength, which means that the objects are farther away. On the other hand, blue shift is a shift in the frequency of a photon toward higher energy or frequency with shorter wavelength, which means that the objects are closer. This diagram shows the concept of Hubble's law, which states that the further away a galaxy is, the faster it is moving away from us. In this diagram, we can see that there is a yellow line that represents the distance. The white and red circles represent the stars. We can notice that the light emitted by a star changes as it moves away from the observer, which shows a redshift. That means that the stars are moving away from each other. Another evidence that supported the Big Bang Theory is the presence of the cosmic microwave background, or also known as CMB, which were accidentally discovered in 1964 by Arno Penzias and Robert Woodrow Wilson. This CMB is considered as the oldest light in the universe, which was also referred as afterglow of the Big Bang that can be detected as a glow which is believed to be a remnant from an early stage of the development of the universe. Because of this belief, the Big Bang Theory obtained the most support from the scientific community among the other theories regarding the origin of the universe. The light of CMB was believed to have been released for about 300 years after the Big Bang. Eventually, the clumping of particles formed the stars and the galaxies that we have now. The discovery of CMB also ended the universe steady-state theory, which tells that the universe is static and unchanging. With the advancement in technology, astronomers were able to observe the cosmic microwave background, or CMB, using different satellites or probes on many missions. One of the most famous spacefaring missions was NASA's Cosmic Background Explorer, or also known as the COBE satellite, which mapped the sky in the 1990s. Other missions have followed in COBE's footsteps, such as the NASA's Wilkinson Microwave Anisotropy Probe, or WMAP, and the European Space Agency's Planck satellite. Planck's observations were first released in 2013, which mapped the background in unprecedented detail and revealed that the universe was older than the previously thought, which was about 13.8 billion years old rather than 13.7 billion years old. Examining the CMB also gives astronomers clues about the composition of the universe. Researchers think most of the cosmos is made up of matter and energy, which cannot be sensed with conventional instruments. That's why it is called the dark matter and the dark energy. Another evidence that supported the Big Bang theory is the primordial abundance of chemical elements such as the hydrogen, helium, and lithium, which are considered as the most abundant elements in the universe. The Big Bang theory predicts that the presence of these light elements should have been fused from protons and neutrons in the first few minutes after the Big Bang. Another scientific theory which has alternative explanations beside the Big Bang is the steady-state theory. This theory was originally proposed by James Jeans in 1920, which later developed by Fred Hoyle, Thomas Gold, and Hermann Bondi in 1948. The steady-state theory of the universe states that the universe is constantly expanding or always expanding. As the universe continues to expand, new matter continuously forms. Eventually, the older bodies became out of sight as a result of their increasing distance and rate of recession. Here, the universe has no beginning and end. Its appearance remains the same over time. Here's an example illustration of the steady-state theory showing density of galaxies that remains constant as universe expands. As the universe continues to expand, new matter is continuously formed. Now we have the cosmic inflation theory, which was proposed by Alan Guth, Andre Steinhardt, and Andy Albrecht in 1980. What do we mean by inflation? Inflation refers to the rapid expansion of space and time. This theory proposes a period of extremely rapid or exponential expansion of the universe during its first few moments. The cosmic inflation theory states that the early universe was a rapidly expanding pure vacuum energy bubble. There was no matter or radiation to it. But due to the extremely hot dense condition of the matter, Big Bang happened. Then eventually, matter began to clump together, forming the stars and the galaxies and other celestial bodies in the universe. This photo shows the timeline of the universe based on the Big Bang and the inflation theory. Started from inflation before the Big Bang expansion. We can also see here the afterglow because of the Big Bang and the development of different celestial bodies in space. The cosmic inflation theory offers solutions to some unresolved problems of the Big Bang theory. First, we have the flatness problem. Imagine living on the surface of a ball, which is a two-dimensional world. The surface that you see is obviously curved. However, if that ball expanded to the size of the Earth, it would appear flat to you, even though it is still a sphere on larger scales to near flatness. With the help of the Wilkinson Microwave Anisotropy Probe or WMAP of NASA, it revealed that the geometry of the universe is nearly flat. Second, we have the horizon problem. Remote regions were actually much closer together before inflation than they would have been with only standard Big Bang expansion. And lastly, with regards to the monopole problem, inflation allows for magnetic monopoles to exist as long as they were produced prior to the period of inflation. The last scientific theory that we are going to talk about is the oscillating theory, which was proposed by Richard Tolman in 1930. Oscillating means a cycle. This theory describes that the universe is a cosmological model that combines both the Big Bang and the Big Crunch as part of a cyclical event. Oscillating theory suggested that the universe passes through successive cycles of expansion and contraction or collapse due to gravity. It means that the expansion of the universe has limitation or end. At the end of the collapse phase, with the universe packed into a small volume of great density, it is possible that a bounce or Big Bang would occur again. The universe would thus oscillate between the Big Bang and the Big Crunch episodes, and so be infinite in age. Here's an illustration of the oscillating theory showing the cycle of the Big Bang and Big Crunch. From Big Bang, it will undergo expansion of the universe until it reaches its limit due to gravity, and then eventually it will turn into small size again, which referred as the Big Crunch, and then Big Bang happens again. To sum it up, we have again the divine creation theory, the creation myths, and the different scientific theories that explained how the universe began. After knowing these things, which do you think best describes the beginning of the universe? That's all for today, students. Thank you for listening and watching with me.
Happy learning at home with lessons made easy by Olivarian GoTeach. One proud Olivarian.